Hi, everyone. So I'm pretty sure many of you have had already some experience of usage of AI. For me, my first experience was using it for network optimization for telecom operators. And that was 25 years ago. Since then, AI has made a little progress solving complex problems like speech recognition, like robotics, and also gaming, whether it's chess, Go, or the latest war games you or your children are using, for instance, Mortal Kombat, which is one of the latest fashionable ones. So you could say there's nothing new in AI, really. But actually, there is. AI is now entering the space of business and critical applications. And there are three reasons for that. The availability of cheap and unlimited computing resources, the availability also of massive amounts of data to play with, and last but not least, the emergence of business models to get value out of the data, as pioneered, of course, by what are called the GAFAM. So, Thales is not yet a GAFAM, yet we have big ambitions in artificial intelligence. But we are also looking into some other properties and performance for artificial intelligence. For instance, ethical usage, to make sure we keep human decision whenever needed into the system. The second is trust and confidence in the results that the AI solutions are providing. The third one is environmental friendliness, meaning maximizing the usage of computer resources we have at our disposal. And the last one, which is part of Thales' DNA, cybersecurity. So over the years, we now have a very large technical toolbox to play with around artificial intelligence. So you start with what I would call the old school of artificial intelligence, which is to use models, scientifically proven models, for instance, weighted decision trees. And for that, you can solve problems of small to medium complexity, but it's very fast, it's predictable, and it can be used in high confidence applications. The second one, more modern, I would say the modern school of thought, is to use what's called deep learning. In deep learning, in fact, you are running data through different layers of neural networks, which is able to solve highly complex problems, even if you don't have a very high human knowledge to start with. The small issue with those solutions is that they are very computer hungry, and there are some uncertainties on the result, in fact, that you get from those algorithms, which make them today a little bit more difficult to use in critical applications. Finally, another area of work is the fact that if AI algorithms run very well in the cloud, in many applications, you want them to run in embedded platforms called edge computers. In that case, in fact, you need to optimize your artificial intelligence algorithms for this kind of usage, for instance, in our world on board trains. So we have those technical tools we play with. What are the use cases? What can we do with AI in rail transportation? I can think of three main usages. The first that comes to mind is train autonomy. And we are in Thales defining a train autonomy roadmap, incremental, to foster AI, in fact, in our solutions for three customer advantages. The first one is operational performance. The second one is an easier evolution of the systems compared to today. And the third one, probably the most important, is to reduce the cost, in particular, reduce the cost of the infrastructures. The second use case for AI in transportation is about video analytics. As trains become driverless, more and more video surveillance, video supervision is needed. So you can think of several use cases for video analytics using AI. One, for instance, is to measure the passenger density aboard trains or in station. A second one is to detect abnormal behavior, either on the station or even on the track itself. And the third one is, for instance, to detect hazards, could be a fire, an incident, etc., that could be done automatically. Then the third application of AI in transportation, it is about optimizing operations and maintenance. You could call that smart operations and maintenance. You could either automate a number of decision processes for operations, or you could support the decisions of operators through clever algorithms. So let me give you some examples of such applications. One would be to optimize the passenger journey patterns through the network. One could be, in fact, to help the operator manage incidents dynamically, quickly, real time, in fact, for instance, by adapting the timetable of the network to whatever root cause of the incident is. So those are three main applications in which Thales is investing on AI for our next generation solution. So as a conclusion, for Thales, AI represents 30 years of research. It represents more or less 20 business cases across the company on all our businesses. For me personally, and for Thales in transportation, I believe that 50% of our product line within 5 years will include AI solutions in there. So it's a very important investment. And once again, and I will conclude on that, for Thales, AI is not just about performance. It is also about the other properties which are absolutely essential for critical infrastructures such as public transportation, which are ethical usage, trust, environmental friendliness, and cybersecurity. Thank you very much.